Next, we're going to work a little bit more with finding domain and range of graphs of functions. So we did one domain and range activity already where I gave you a bunch of graphs and you had to write all the domains and ranges. I'm going to give you a couple of more activities like that as well, because getting practice with domain and range is very important. Now remember the definition of domain. Domain are your x values, okay? And range are your y values. So over the years, I've had different students tell me, how do they remember that? And the one that I'm reminded of the most is I had a student once who said, well, I don't call it domain and range. I call it domain and rangey. And he added the y to the end of the word range. And he says, I never forget that range has to go with y and domain has to go with x because of that. So he called it domain and rangey. If that helps you remember, if it's something silly like that, often if you can create ways to remember things that are unique, they'll help you. A very common way to remember things is alphabetical, but it doesn't always work. And so in this one, oh, x comes before y and domain is d, which comes before range is r. It could work for this one as well, but there's so many situations where it doesn't work, and if you use the strategy too often, you're not going to remember, was this one where I used that strategy or I didn't? And then you won't remember. So if you can think of something crazy and unique, then you'll probably remember it. All right, here we have the graph of negative 3x plus 7. Find the value of the range when the domain is x. This translated says find the value of y when x equals negative 1. So we go along our x-axis and say, well, negative 1 is right here. Do I have a point on that graph when x is negative 1? Yes, I could go up to the graph and say, there's the point where x is negative 1. What's my y value? That point is at negative 1. The y value, 2, 4, 6, 8, 10. The value of the range when x is negative 1 would be 10. Find the value of the domain when the range has a value of 4. So we know that the y value has a value of 4. Do we have a point on our graph? Yes. It's something comma 4. What would our x value be there? 1. So we find the point on our graph which has the correct domain or range value, and then we can find out the other value from your graph as well. Okay? So I'd like you to try this one on your own. All right, let's see how you did. When the domain is 3, did you get a range value of 9? And when the range value was negative 7, get a domain value of negative 1? Question 6, draw a graph that represents the information. Okay, we would put altitude down here and temperature here because whatever is in the first column is always our independent and what's second is our dependent. And so at 6:10 we have a temperature of 15. 12:20 we have a temperature of 11.1. 18:30 7.1. 24:40 3.1. 30:50 negative 0.8. And then negative 4.8. Makes a nice straight line. So when we draw a graph, we label our x-axis and y-axis with a scale. The scale needs to be the same. You can't change the spacing in between. So I decided to go by 4s along my y-axis, and I decided to go by 610 along my x-axis. Also good to include a title for your graph. Temperature in relation to altitude. In the second example, we've got age in years and dose of vitamin C. So we've got age there, years there, a nice title. Dose in relation to age. $15, $25, $45, $45, $65, $65, and $75. Now some more practice with domain and range. So determine the domain and range of these functions. A couple of things that we're going to talk about I'll put off to the side. From a graph, and we saw this before in our first example, if you have a point that's a circle that's closed in or colored in like that, that means that the point is included. And if it's an open circle, it means the point is not included. But your graph gets as close to that point as possible. A couple other things that textbooks do, if the graph ends at the edge of the graph, they want it to mean that it continues on forever. Whenever you are drawing a graph, you need to show that it continues on forever, so I want you to add an arrowhead to the end of the graph at that point. Whereas in part B, both points where it ends in part B end at a specific spot. They don't end at the end of the graph, so we know that it stops there. So in part A, the domain. The domain are our x values. And so in this case, we want to think about which x values are possible. We're not just going to list 2, 1, 0, -1, -2, because the graph is joined, which means it includes every single point in between. One of the things that I think about for domain is I think about what's my smallest x value, what's my biggest x value. Since there's an arrowhead here, this means that this graph continues to go up. It also continues to go to the left. And it will continue forever. So it will go up forever. It will also go to the left forever. But when we look at the maximum value, we can see that it stops here at 3. So you have every x value from -infinity all the way up to 3. How do we show that for our domain? Okay? Now, moving forward, okay, I'll show you the fancy, all the details way first, and then show you what's usually accepted moving forward. So fancy, we'd start with the squiggle brackets. We would say we're finding our x values such that x is less than or equal to 3, and x can be any real number. Whew. That's the fancy, all the information way. It's saying that your x values This straight line in math means such that, so obvious, right? The x value is such that x is less than or equal to 3. Now you will get full marks if you just write x is less than or equal to 3. You don't have to add all the extra information. They will assume you mean all numbers. And remember, this symbol means all real numbers. They'll assume that you mean that. This type of way of writing domain is called set notation. There's another way that you can write domain and range, and I'll introduce that to you now. It's called interval notation. In an interval notation, an interval means starting from one place, ending in another place. Okay? In an interval notation, you start from your smallest value and you end at your biggest value. Remember, we talked about this one having no smallest value because it keeps on going forever to the left. So the way that we show that in interval notation is we say we start at negative infinity. And then what's our biggest value? Our biggest value along x was positive 3. And we use a square bracket when something is included. Since 3 is included, we use a square bracket. When something's not included, we use a round bracket. And with infinity, we always use a round bracket because it's like, can you include infinity? Yeah, it's kind of a abstract concept to begin with, so we use a round bracket. For the range of this one, in set notation, in all the fanciness, we would go y such that y is, well, does it have a smallest value? Yes, the smallest y value is right here at negative 1. Does it have a biggest value? No, because the arrow goes up forever. So we would say that y is bigger than or equal to negative 1. That's the fancy way with all the extra writing. Okay? If I asked you this on a test, I would be fine if you just wrote y is bigger than or equal to negative 1. So why am I showing you the fancy way? Well, if there was a multiple choice question and they had all the fanciness written there and you'd never seen it before, you'd be like, and then get afraid and leave it blank or something bad like that. So introduced to it so you know that a whole bunch of this information you don't really need. It's just y is bigger than or equal to negative 1. But if you see that, you're not scared by it. In interval notation, it has the smallest value, negative 1. Negative 1 is included, and it goes up forever. So then we would have infinity on that side. If it says find the domain and range, usually it won't say which type of notation, and you get to choose. So you can say, oh, I like this one better than that one. Okay? Let's look at the second example. Are you okay if I erase my answers here? Everybody got them down? So I'm going to just erase the answers for this one and for this one. And now we're going to do part B. Set notation, starting with domain. Do we have a smallest x value? Yes. Negative 2 is the smallest x ever gets. Do we have a biggest x value? Yes. Positive 2. In set notation, we would say that x is bigger than or equal to 2, but less than or equal to 2. I'm sorry, bigger than or equal to negative 2 and less than or equal to 2. That would be the short way. That's all you would need to write. Okay? The long way, x such that negative 2 is less than or equal to x, less than or equal to 2, where x is a real number. would be the long way. In interval notation says start at your smallest value, -2, end at your biggest value, +2. Use square brackets on both because they're both included. And for our range, I'll just write the short way. Can you see that your smallest value for y is 0? Your biggest value for y is +2. So we would say that y is between 0 and -2. We would have equal signs with your inequalities because those points are included. In interval notation, smallest is 0, biggest is 2.